Do you know what's the alternatives of recycling plastic waste other than reusing? The answer is electrospinning. Assalamualaikum and hi, I'm Nordini Safia binti Muhammad Abdul Azam. Will present my final year project, the characterization and electrospinning of recycled LDPE and expanded polystyrene. Plastics have been continuously used since their invention, resulting in massive daily production of plastic waste. This concerning trend, particularly with plastic bottles and packaging, poses environmental risks and calls for innovative recycling strategies to maximize profits. Negligent disposal of polyethylene, a commonly used plastic, can harm ecosystems and wildlife through litter and the release of harmful chemicals during production and disposal. The burning of expanded polystyrene (EPS) is prohibited due to the potential generation of harmful gases. EPS pollution significantly contributes to plastic waste in oceans, posing long-lasting environmental consequences. To combat EPS pollution, efficient waste management and recycling programs are crucial. Transforming plastic waste into nanofibers through fiber electrospinning provides an opportunity to reduce the production of new plastic items, minimize environmental impacts, and repurpose plastic waste for various applications. Global synthetic polymer plastic production reached 332 million tons in 2015 and 359 million tons in 2018, with Europe accounting for 29.1 million tons. Only 32.5% of these plastics are recycled, while 24.9% are landfill and 42.6% are burned. Limited research exists on recycling specific plastics like LDPE into nanofibers through electrospinning, as most studies focus on other types like PET and polyethylene oxide. EPS recycling faces economic challenges due to its high air content, necessitating alternative recycling methods. The growing plastic waste poses environmental and health risks, emphasizing the need for alternative solutions. There are 4 objectives in the study. First, to characterize recycled LDPE and expanded polystyrene, to produce nanofibers, to determine the characteristics of nanofibers, to determine the concentration of recycled plastics that can produce a good quality of nanofibers. Fiber electrospinning is a versatile technique for creating tailored electrospun fibers with precise properties such as fine diameter, high surface area, and customizable composition for various applications in diverse fields. Based on previous studies, research has been done on PET and TPU nanofibers by electrospinning that was done by Guo 2021. Before electrospinning, the characterization process of recycled LDPE and EPS was begun with FTIR, then tensile strength test by using Instron tensile testing machine, then density test by using densimeter. The process of making solution by dissolving different concentration recycled LDPE in xylene and toluene solvent were failed due to the absence of heat because of the process was time-consuming. The material was replaced with different concentrations of expanded polystyrene and mixed it in xylene solvent, and it was successfully dissolved. Then, the viscosity of the solutions of different concentration of EPS and xylene were tested by using viscometer. This test cannot be done to recycle LDPE solution due to the unsuccessful solution making. Then the solution of different concentration of EPS and xylene were used for electrospinning. Then the product from electrospinning were observed under a microscope. The FTIR spectra of the recycled LDPE shows complete, well-illustrated spectra. The CH2 stretching vibrations of main chain were observed at 2916.3 cm inverse and 2850 cm inverse. The FTIR spectra of recycled LDPE and virgin LDPE from past research by Hadir 2022 almost look similar. However, it has 2 groups that differ: the virgin and recycled LDPE. Firstly, C double bond O stretching vibrations appeared at 1723.8 cm inverse, and the next is CO stretching vibrations appeared at 1231.8 cm inverse and 1108.5 cm inverse. Almond et al. 2020 mentioned that the C double bond O stretching vibrations shows weak carbonate bond that also indicates the oxidation of polyolefins. The FTIR spectrum of expanded polystyrene show absorption peaks at 2922.8 and 2854.4 cm inverse that shows the stretching vibration of CH bonds in the blowing agent. Blowing agents are substances added to the production of foam plastics. They offer benefits such as lightweight properties, material and cost efficiency, and thermal insulation capabilities. These additives play a significant role in creating foam plastics that are lighter, more cost-effective, and provide effective thermal insulation. Based on past research by Al-Kadami and Rashid 2013, the FTIR spectra of virgin polystyrene shows characteristic absorption peaks at around 3060 to 3020 cm inverse, the stretching vibration of aromatic CH bonds. Based on the data of tensile strength test, recycled LDPE and expanded polystyrene, for all parameters, recycled LDPE scored the highest. Same goes to density test, recycled LDPE has the highest density. Recycled LDPE and expanded polystyrene are two different materials, so they have different properties. The differences in the properties of recycled LDPE can be ascribed to factors such as variation in the recycling process, potential impurities present in the recycled material, and the influence of different sources or batches of LDPE. According to Zozias 2020, the consistent properties of EPS can be attributed to its manufacturing process, which guarantees uniformity in its structure and composition. Recycled LDPE in xylene and toluene solvent were failed due to the absence of heat. Because of the process was time-consuming, the material was replaced with different concentrations of expanded polystyrene and mixed it in xylene solvent. The data from viscosity test shows the viscosity of different solutions of different concentrations expanded polystyrene with xylene. From the data, the viscosity increases with concentration. This shows that concentrations affect viscosity. According to Yadav et al. 2010, raising the concentration of solute leads to a rise in viscosity, primarily due to the added energy needed to move or rotate these molecules within the solution. The production of nanofiber by using the solution of expanded polystyrene and xylene was failed. When the product was observed under microscope, the product was in beads and droplets and no string of nanofiber. This may due to the low concentration of expanded polystyrene. Based on past research by Rifate et al. 2023, the concentration of the polymeric solution greatly influences the stretching of the charged jet. At low concentration, the combined effects of the applied electric field and surface tension cause the entangled polymer chains to break up before reaching the collector. This results in the formation of beads or beaded nanofibers, leading to a high average fiber diameter until a critical concentration is reached. To conclude this research, the chemical bond in recycled LDPE and expanded PS were identified through FTIR. Compared to expanded polystyrene, recycled LDPE has higher density and tensile strength due to the different composition and chemical structure. The viscosity of recycled LDPE was not identified due to the insolubility during solvent preparation. The viscosity for expanded polystyrene are increased with concentration. Higher concentration can produce good quality of nanofiber. I suggest a few recommendations based on this research. Researchers should consider higher concentration of expanded polystyrene above 10 weight percent to observe the impact on the quality of nanofiber. Second, researchers should consider to use other type of plastic waste and variety of solvent. That's all from me. Thank you.